Hello, Algebra 2 students. Here is a recording for you to assist with your review of Chapter 5 and to help with your homework if necessary. It is section 5-5, Roots of Real Numbers in the Study Guide and Review. It starts on page, it's on page 278. And follows the factoring of polynomials on page 278. It's 5-5, Roots of Real Numbers. And there is a concept summary box displaying all of these roots and what to look for. And it says, in the title it says real nth roots of b, and it has an open radical with the nth root of b, or a negative open radical with the nth root of b. So then underneath the title, it has a row where what would your n be? And so if your n is actually that's a column. I'm sorry that I called that a row. If your n is even on that column or odd. So if you follow that over, if your n is even and you have the nth root of b where b is greater than 0, one positive root and one negative root would be what you would end up with. So in other words, if you have like the square root or the fourth root or the sixth root, you could have a positive and a negative root. If you have your b is less than 0, then you would have no real roots. Okay? No real roots on an even if it's less than 0, because then we're looking at the negative square root or negative fourth root or negative sixth root. That wouldn't be possible for real roots. Now we've learned that there are complex numbers or imaginary numbers that, the I helps us out there. But as far as real roots, there aren't. And then if b is 0, so if you have the nth root and b does equal 0, then you have one real root, and that is 0. The fourth root, sixth root, eighth root of 0 is always going to be 0. Then if your roots are odd, you would have one positive root and no negative roots. So in other words, if you're looking for the third root of a number that's greater than 0, the fifth root, the seventh root, you'll get one positive root, no negative roots, because if you had a negative times a negative times a negative for a third root, well, then the answer would be negative. And if your b is less than 0, you have no positive roots, but you do have one negative root. So in other words, if you have the third root of negative 27, it would be negative 3, because negative 3 times negative 3 is positive 9, times negative 3 is negative 27. And then again, if you have 0 as your root, you're going to have 0, one real number, and it's going to be 0. Okay? So that just summarizes what happens with your roots. It's kind of common sense if you derive it yourself, if you ask yourself how you would get there. So take a look at the examples. We have example 1, says simplify the square root of 81x to the 6th. So you got to break this down into squares. And so notice that's what they did in the example. They said, well, it equals the square root of 9x to the third all to the second power, because if we apply that second power to 9, it would become 81, and x to the third to the second power become x to the 6th. So we broke this up into a square. So therefore, the square root of that would be 9x to the third. Now notice they put the x to the third in an absolute value because we have this even, right? Even root with our with our b greater than 0. So we got to have one positive, one negative. So they're saying the absolute value of x to the third, because if it became negative, that wouldn't work under the square root symbol, would it? Because we wouldn't have, it wouldn't have, can't go negative. So that's why you put the absolute value to keep that x to the third positive. Notice on example 2, it's the square root of, or excuse me, the seventh root of 2,187 x to the 14th y to the 35th. Seventh root of 2,187 x to the 14th y to the 35th. So notice they broke that up into perfect seventh powers, right? They said, okay, well, 3 to the seventh power becomes 2187. You probably want to use your scientific calculator for that. X to the second, because x to the second time to the seventh, that 2 times 7 would become 14. Y to the fifth, because the fifth, y to the fifth to the seventh would become 35th. They put that all in parens to the seventh power, because if you applied the seventh power to the 3, you would get 2,187. Seventh power to the x to the second power, you'd get x to the 14th. And seventh power to y to the fifth, you'd get y to the 35th. So we got that all into the power of 7 under our seventh root. So that then becomes, the answer is 3x to the second y to the fifth by breaking it into the seventh powers. So those two examples show you how to break up your roots, okay? And you'll do those in exercises 35 through 42. 35 through 42. So in math speak, very quickly, I'll give you those and give you the answers. 35 is plus or minus the square root of 256. Okay. The answer is going to be plus or minus 16, positive or negative 16. 36 is the cube root or third root of negative 216. The answer is going to be negative 6. 37 is the square root of open paren negative 8 closed paren to the power of 2. And the answer is 8. 38 is the fifth root of c to the fifth, d to the 15th. And the answer is cd to the third. 39 is the square root of the quantity open paren x to the fourth minus 3 closed paren to the second power. And the answer is the absolute value of x to the fourth minus 3, absolute value close. 40 is the cube root of open paren 512 plus x to the second closed paren to the third power. And the answer is 512 plus x to the second. And 41 is the fourth root of 16m to the eighth. And the answer is 2m to the second. And 42 is square root of a to the second minus 10a plus 25. And the answer is the absolute value of a minus 5. All right, that's it. Take a look at that video, watch it several times, and do the homework.